Okay, as I mentioned before, law of cosines is basically the Pythagorean theorem. We're just gonna see what happens when we don't have a 90-degree angle, and that's how come we can do it with three sides, and we can also do it with only two sides and an angle. Okay, so let's verify. So let me get this. I'll make sure to actually open up the triangles for all of them. So this is the Pythagorean theorem. Verify that the right triangle hint. If it's not the right triangle, must have 552. Okay, so verify it's the right triangle. At the sum of the areas of it. So it's just saying a squared plus b squared equals c squared. So I'm just going to put that in here just to kind of do it. It says area because these are all squares. So in order to do this, I'm just going to state a squared plus b up squared equals c squared. And they don't even give us the sides, it looks like. It just gives us the actual square itself. I'm assuming so because this looks like, wait, no, 12 isn't a perfect square. So what I'm going to do here is I'm going to plug in all the sides. Okay, so 12 control up squared plus control up squared equals 20 control up squared. So 12 times 12 is 144 plus 16 times 16. Unfortunately, I don't have memorized. So you can use their calculator, but I like using mine. 16 times 16, 256. 6 equals 20 times 20 is 400. It's just 2 times 2 is 4. And we're going to double those zeros. And this works out. So that's what it means by verify it. Um, Also, you could find the area, so you can use the area thing to measure it if you know how to do that. All right, so moving on here. Now change the angle, and we're going to do this. So in order to do this, I'm actually going to use the area thing. So defect of that area defect of 2. See? I don't know what it means by area defect. Hold on. Change of the area as you be. You'll notice the area defect of a rectangular area is formed. Okay. So let's change this, and it looks like that's gonna cause what they're talking about. And I don't know why my undo button doesn't work. Okay. So let me grab this. I'm going to move. Okay. So now we have this thing called area defect, which honestly they don't do a good job explaining, but I guess I'll try to explain it myself if I can figure out. This is a weird way of kind of doing it. What they're saying here is it changed basically. This is what it the area that it no longer is. Um, which I think is a weird way to kind of teach this, but I think they're just trying to teach it really fast. So a squared, so I'm assuming they're already doing this. That's 15 point. Let's see this. 15.71. 15.71. Area defect one. So the area defect one would be 7.95. 7.95. I was wondering how they were going to teach this, but I didn't think they would teach it this weird. Okay, so B1. Do they have a B1? They don't even have the B1, do they? Let me see here. Well, they have the area defect 2. A, B. Oh, okay. They want me to calculate this. Okay. So that's really weird. 15.71 squared. So they're going to want you to square this. Okay, so we get this number right here. I'm assuming that's what they want me to do. This is still going to be 256 because we didn't change that 16. Area defect. And then the area defect is 7.86. Okay, so to calculate a squared, that records the listings two decimal place values. It's two decimal place values. That's this. Um, area defect. I'm just assuming I'm plugging in the area defect because it doesn't tell me otherwise. 7.81. 1. I'm hoping this is it because it is very weird. I've never seen it this explained this way before. So let's see if we're doing this right. Um, C is 15.9, so we're going to want to do 15.9 squared, which is 252.81. So 252.81. Um, I hope this is the way they want you to do this. So I'm actually gonna hit submit here because this is very weird, and I feel you guys would benefit more from the actual answer than from me trying to figure out what they're trying to say. You'll notice the defect or a rectangular area is formed. So let's just take a look here and see what they wanted us to do. Okay, so they did want us to square it. So I got some of this right. 16 squared. Okay, so these are all going to be the same. These will change apparently. So you can see here as the angle decreases. I'm sure you guys are just looking at the answers by now, but you can see here as this angle increases, the side here is going to increase until we get a little bit over 90 degrees. You'll see that it starts decreasing again. So that's what's happening there. And apparently we have to multiply it. So they wanted us to calculate the area. I feel like they should have calculated and recorded the areas. So you'll notice the defect rectangle. See, they call it a rectangular area, which I feel is incorrect. So this is the work you guys want to show. You're going to square what the A's change into and put that there. Then you're going to square these. These should all be the same. So you can just put that. Then you're going to have to take the defected area times this. I personally feel they could have done this a little better. Um, what eventually is supposed to happen is they're going to have us take this, subtract the defect area, and then they're going to have us take this and subtract the defect area. They're basically just like, hey, it would have been a square, but we have to get rid of this triangle. They just did a terrible job of explaining that this B1 is essentially the length of what's being cut off. So we'll do that. So do the area of that plus that. Okay, so we're going to add these two together and subtract the defected areas. So hold on. a area of a squared plus b squared plus area defect plus area defect. Okay, so we're doing this one, we're adding it. So the first square, we're adding the areas and subtracting the defect areas. And the second one, we're just adding everything together. So that's how you're going to end up doing this. You're going to take this portion right here, add it to this portion here, and then you're going to subtract this and this. So when you're doing this, make sure you're showing your work. I'm going to do a quick submit, that way we can see the answers, because I feel showing the work is going to take a lot of time, and you guys can just pause it and use all the time that you need for this. So here we see add, subtract the first area defect, subtract the second area defect, we get this, and then we have add this, plus, plus. So we have this, uh, what are we doing here? Add. So this is adding all of them together. And we see that, why is it the same? That's kind of weird. A squared, b squared, minus the area defect, minus the area defect. And this is added. Oh, okay. I see. They're showing that if we do the area defect, it's going to be the same as c squared. So c squared, that one is basically changing. Our c kept increasing in length. I didn't show that last time, but our c increases in length, and then after 90 degree, oh, even up to 90 degrees, except that 120 it starts decreasing. So that's kind of interesting. Then we can see here how the a squared plus b squared minus that area defect, which we're going to get into in a little bit. This is a strange way to teach it, guys. I'm sorry. But again, you guys can pause here to show your work. Make sure you're showing your work, how you're adding them and subtracting them. What relationship between the areas do you observe when measurement of angle BCA is less than 90 degrees? And when measure angle greater than, oh, okay. So what I was saying here is, remember how I said if it's less than 90 degrees, it starts increasing, but when it starts getting greater than 90 degrees, they start decreasing again. So when it's less than 90 degrees, let's take a look at the actual completed chart here. So these are all the same. So when it is, how do I say this? When it is less than 90 degrees, we see that A is bigger than B, right? So you can see that here. A is bigger than B. But after that point, it starts getting small. Well, they are phrasing this weird. So I'm just going to say this. As we get closer to 90 degrees, the side A and C increase. As we move past 90 degrees and more, side A and B decrease. So this is my assumption of how this is going to be. But I just, so when area of CA is equal to that, when it's less than, okay, this is weird. Okay, so when it's less than 90 degrees, it's saying that these are equal, but when it's greater, they are not equal. Um, Oh, I see. I see what they're doing here. So when we're less than 90 degrees, we're saying that these two are equal. The subtracting ones are equal. But when we get greater than 90 degrees, we notice that this is equal to this. So that's what it's saying here. Please use your own words. So what it's really saying is, ugh, I would actually copy and paste part of this. So when it is less than 90 degrees, c squared equals, I'm just going to copy this. When it is greater than 90 degrees, c squared equals this. So when it's greater than 90 degrees, you're going to want to add everything. When it's less than 90 degrees, you're going to start subtracting the defunct area. And we'll see that a little bit more here. So let me see if I can move this B still. So once you get over here, you need to start adding the area because this C squared is getting a lot bigger is what it's saying. But when you get smaller than 90 degrees, this is becoming so tiny that you're going to want to take the area of the squared and subtract these two areas. Now let's try to write it using trig formulas. Honestly, I feel that they are expecting way too much from you guys to prove these. I will show you the answer and I will explain it as best I can. But for you guys to derive it from this, I think it's very difficult. So I will show you the answer. However, you should use your own words and I will explain it. So please listen for these. So for this, since it's a right triangle, we can say that cosine of C equals that. Okay. Oh, so this was saying. So now write equation starting with an acute angle using trigonomic ratios between that. Okay. Why did they make it sound difficult with the areas of this and this and okay. So they're saying that if we have this right triangle, we can say that cosine of C equals B of, oh, I see. Okay. B1. B of 1. So they're saying, how can we figure out this side right here, this B1? Well, if we look at this is a right angle right here. So cosine of angle C, where are they getting their angle C from? Cosine adjacent over hypotenuse. Oh, wait, this angle. Gotcha. So what they're saying here, and hopefully my pen goes good on this. Sometimes it has a little bit of trouble with this. So it's saying if we look at this triangle right here, oops, if we look at that triangle right there, this is going to be the adjacent over the hypotenuse. But, oh, actually, there's no but. I was going to say we're going to talk about side A, but we actually don't have to. So that side's actually really easy to explain. So, in other words, B1, B of 1 is equal to this. So, let me kind of explain that a little more. So, first of all, remember SOHCAHTOA. So, Ka, adjacent over hypotenuse. So, they want us to do this. So, they're saying cosine of C equals our B1 over our this entire side right here, which is our A. But we want to solve this for B1. So what I'm going to do here is I'm just going to multiply both sides by A, and that's going to give us B1 equals cosine C of times A. I'll put the times A there so we know that the C is the argument. Okay. I don't know why they phrased this very weird. Again, I'm going to show you the answer for this next one and explain it. So use this equation for a variable B1. Okay. So that was the de facto area, right? Yes, no. Now we'll try to write the formula using this. I feel this is a very, very weird roundabout way of teaching this. I'm sorry. Um, so use the equation you wrote 5. I understand why they're doing it though, because if you guys don't type it in yourselves, you'll probably skip the slide. So the variable B1 should not appear in the formula. So use the formula. So write the formula you wrote in part A. Okay. In terms of triangle ABC, variable B1. Write the equation you wrote. Oh, okay. For triangle ABC. This is where Edmentum. Okay. Use the formula for area of a rectangle. So use the formula you wrote in question 5 to express the defunct area. Oh, okay. The defect area. So in other words, the defect area here. Okay. They really need to come up with better names. So they want us to find this area here. Okay. So if we want to find the area there, we're going to need this B, right? So if we're doing it that way, we want this side B right here. So we're going to do B. So let me kind of replace this in. So the area of that is simply going to be B times B, scroll down, B sub 1 equals defect area 1. Is it 1 or 2? I don't even know. It's 2. Oh my gosh. Defect area 2. All right. So, the variable B1 should not appear in the expression until defect. Okay. So this is it, but we can't use that B1. So what we're going to do is we're going to use substitution with the formula we just did over here, which is A cosine of A. A cosine of C. I don't know why I said A cosine. So this should equal our area right here. So submit it. So that's just length times width. They're just making it sound very complicated for some reason. So we get this AB cosine of C. All right. So if it's acute, so now we want to do it for an acute triangle, which is what we did before. This time, what are they asking? Use a trigonometric function to find a sub 1 to b. Okay, so b is this, a sub 1. So this is side b. This is our shorter end. We're going to say that this is a 90-degree angle. So this right here is a 90-degree angle. So, oh my gosh. Using B, or side B. If it's a Q, okay. So if this is a Q, we are looking at this. Oh, all of A. We're looking at all of A in relationship to side B. Okay. A. I kept thinking A sub 1. Oh, wait, it is A sub 1. A sub 1 to all of B. So this little thing to all of B. Okay, so in other words, we're trying to find the relationship of this side right here to the relationship of this over here. Okay, so when we're doing that, we're going to have to use this angle A. Or does it want us? If it's a cute triangle, ARC is a right triangle. Yeah, we know that. So it's a right triangle with that. Okay. So I'm assuming they want us to use this. So if they want us to use this, we're also going to use, we are also going to use, give me a second here while I erase all of this. Oh, I meant to use leave the cosine there, but okay. We're still going to use cosine. So we're still going to use cosine of C because they want us to keep using this C here. Cosine of C. And it's going to equal our adjacent. In this case, it's the little pink side, which is going to be the A sub 1. And we're going to make that over our B. So in other words, we have this. Oh, I need a faster way to do this. A sub 1 equals uh, B times cosine of C. Okay, so we're going to write that down here. I'm going to use my equation editor. I'm actually going to start typing using these because this is getting annoying trying to do all these. Fraction A control down 1 over B, therefore A control down 1 equals cosine of C. We're going to multiply that with our B. Okay. I see where they're starting to connect all of these together. Still not a big fan of how they're teaching it, but will prevail. Use the equation used in part 7 to measure this. So again, we're going to use this area, this A here. Okay, so let me erase everything. And we're going to use this A because this is an A squared. So all of this is the same. A times this A sub 1. So we're going to start off like that. So I'm just going to write it in and then just hit submit using my pen. So we're going to say A sub 1, the area of the whole rectangle. So I'm going to, this A sub 1. So A sub 1, not A sub 1. We'll say area equals A sub 1, which I wrote in pink, so I'm going to keep doing that. A sub 1 times our regular A. And instead of writing A sub 1, what I'm going to do is I'm going to write that B. So I'm going to write A times the formula we did over here, which was B cosine of C. So that's what we're going to do. I'm just bringing this here and replacing it in. So I'm going to hit submit so you guys can see that. So we get that B. So we get this B cosine again. All right. So now using the relationship found in question 4, when angle C is acute area of this. Okay, so we're going to do a squared plus b squared, and then we have to do minus the defunct area minus the defunct area. Combine your observations. Now, here's the interesting part: is that cosine can be positive and negative. So watch this. So let's see here. If I do it this way, notice how our b all of a sudden now becomes negative, right? So here it's positive, but over here it would technically become a negative number. So that's good for us because it's going to cancel everything out. So result of this and relating the angle side. If you follow this logic, oh my gosh, they're going really into this. I was just going to tell you guys, hey, look, this it would be positive, this it would be negative. Or I'm sorry, opposite actually. This would be a positive number because our cosine would be positive. It creates a positive number. Over here would be a negative number because it's going in the opposite direction. So when it's bigger than 90, we would be adding it. But when it's smaller than 90, we would be subtracting it. So that's all you really need to know officially to do this. They want you to do a little bit more. So I'll kind of go and explain. It took me a while to understand how they were trying to teach it. Um, I've I've tried looking these over, but I rather do a discovery with you guys as I'm recording it. So this would be positive. So when it's bigger, we're adding them. When it's smaller, we're subtracting them. So that's where the cosine and positive cosine come into play. So if I add this, what it's saying is we're adding the defunct area. So check this out. So we already said we're subtracting the defunct area, we're subtracting the area. This is the formula we did for subtracting. This is the formula we did for subtracting. So this becomes a negative 2 of the same side. Basically, these little rectangles are equal to each other with respect to C. Depending on what C is, these two angles will end up being equal to each other. So we can just say that. All right. So now we're going to do it assuming that they're perpendicular. Well, we already know that they're perpendicular. So it's either going to be either if we're solving for a, so if we're solving for this a squared, we're going to be talking about different triangles. Before we were always talking about C. We were always talking about subtracting. Now we can actually flip it and talk about all the other ones. So you can just write when we talk about the other triangles. So in here we would write when looking at the other sides, we would change the angle and one of the sides. So you just say that because if we're talking about angle side A, for example, we're going to switch this to be angle A. And obviously we're not going to have C here. We're going to have it over here, which means you're going to have to replace the B, or I'm sorry, the A. The A kind of switch place. So that switch places. If you want to solve for side B, you'll see that the B switches places. And the capital letter is always going to see. So anywhere you switch these, basically it's the same formula for all sides, is what I'm saying. So do it that which you wish, and remember to make a sentence in your own words. Now all kinds of problems can be solved using this. So if we look at that, what I mentioned before is what they're talking about here. If you have two sides and an angle, you can solve for the third side. If you have all three sides, you can solve for any one of the angles in there. So this one, I would give myself a 3, to be honest. The wording was very awkward and it was difficult to understand. understand what they were asking. And this I've noticed is a common pattern with geometry. It is built for people who know what the activity is to understand it, than it is for you guys to learn it on your own. So that's why I'm giving you the perspective of kind of both as a math teacher, figuring out with you, but not understanding what the end goal is. So it's that discovery phase with being able to explain it to you. So that's what we're doing here. So in other words, you can use this formula if you want to figure out an angle and know all the sides, or if you don't know a side but you do know an angle. So you can figure out the third side by you can figure out a third side if you have two angles and the side, or if you have all three sides, you can figure out any angle. So you either need two sides and an angle or all three sides to really use this formula. So let me just submit this so I'm able to go down. I didn't realize I hadn't submitted all of them yet. There you can see that I did put it the way they wanted. And one of these I didn't hit submit for. Oh, this one. Using the Pythagorean theorem to solve it is what I didn't show. All right, so here, this is what we're saying. And this is always true because, like I said, if it's larger, it's going to be positive. The cosine will spit out a positive. But when it goes to the other side, it'll be negative. So this will always work, in other words, whether it's greater than 90 degrees or smaller than 90 degrees. This is all you really need to know from it. I recommend writing these equations down for when you're taking the mastery test. Okay, so let's take a look at these. If the length of a side is 6 centimeters, okay, so I really wish they put their pictures with this. I guess this is good practice for you guys to always make your own pictures. So if the length of side A is 6 centimeters, so this is 6 centimeters, and the length of side B is 4 centimeters, we need to, and this is 7, and we want to find the measurement of angle B. So this is the measurement of angle B. Okay? So what we're going to do here is, give me a second while I figure out, we're solving for big B. So if we're solving for big B, oh, they haven't even shown you guys how to do this yet. Okay, let's get into this. So we need to do little b equals, let me try to use different colors for all of this. Little b equals a, oh, you know what? I'm just going to write the whole formula down and then I'll explain why. So b squared equals a squared plus c squared minus 2ac. We're always using these angles, cosine of our opposite angle, which is b. So if we're solving for this b, this capital B, we're going to need to have little b on this side. Okay, so now I'm going to just plug everything in. Well, little b is 4. So I do 4 squared. Let me do another color because that looks terrible. 4 squared equals, and then I'm going to do my little a. Little a is this. So I'm going to do 6 squared. And then I want my c. So I'm going to do plus 7 squared. I'm going to do minus 2. My a again. My a, I think I did kind of an orange. 6. And then my 7. And these have to have parentheses because it's all multiplication. Cosine of b. So when you're doing these, you have to square them individually. So when you're squaring these, you're going to do 36. You're going to do plus 49 minus all of this together. So 2 times 6 times 7. So what I'm going to do here is I'm going to do 2 times 6 times 7, 89. So I'll do 80, 89 or 84? 84. I don't know why I said 89. I'm sorry. Cosine of b. Now, this is very important. This is stuck to this cosine. So you do not want to just add and subtract all of this because they're not like terms. So what we're going to do here is this ends up being 16 because 4 squared is 16. Now I'm going to add these two together. So in order to do this, I'm going to add those two together. So there's going to be 16 equals, I'm going to 36 plus 49, 85. So this equals 85 minus 84. Again, do not combine those. I know it's very tempting. You're like, oh, that's just one, but it's not. Okay, so now in order to do this, I have to subtract 85 from both sides. So I end up getting this negative something. Let me get that negative right now. 16 minus 85, I end up getting negative 69. Negative 69 equals negative 84 cosine of b. And I'm sorry, it's so tiny. Imagine this is even worse if you're looking at this on your phone. So here I'm going to do 69 divided by 84. And I'm going to, so I get 8.2. So I get this fraction, 0.8214 equals cosine of b. So if I want to find b, I have to find the inverse cosine of this. So I'm going to have to find the inverse cosine of this. So I'm going to do go here. I'm going to do 0.8214, and I need to find the inverse cosine. So I'm going to use my trig function, and I need to use the inverse. I'm going to use inverse cosine of this, and I get about 34.77 degrees. So let's see how picky this is. Round 2 decimals, so 34.77 degrees. All right, cool. And they said that was right. Okay, so that's a really long process. I know it was long, but hopefully they give us another one to practice. So we have to plug everything in here. I will probably do the Kahoot based off of this. So let's kind of get into that. All right, so if the length is A, okay, so again, I'm going to do all of this. I'm going to do length of A is 16, length of B is 10, and the measurement of angle C is 22 degrees. So we do have the measurement of angle C, this, so we need to find angle C. So obviously, this one's a lot easier. I really like it when it's this, because this you can just plug into a calculator. C squared equals A squared plus B squared. Remember, this is not the Pythagorean theorem. We still have to add the minus 2AB, these two sides. So if we're solving for this side, all of the right side is going to be the other two sides. So this is going to be cosine of 22. Oh, I forgot. I'm not plugging anything in yet. Got a little ahead of myself there. Cosine of C. So once I plug everything in, so the actual work begins. C equals A squared is this 16. So 16 squared plus B squared, which is 10 squared, minus 2. Our A again is 16 and our B is 10. Cosine of, this time they did give us this. These I find easier because you just pop the side here and then you solve for the rest. So now what we're going to do is I'm just going to open up Desmos, the Desmos scientific calculator. So if you don't know how to find that, you go to desmos.com. You're going to go to Math Tools, and you're going to do scientific calculator. And you can actually just plug this whole thing in. Now, keep in mind, since we're solving for c squared, you want to do c is square root of all of this. And luckily, as long as you're using Desmos, you should be fine. Using a standard calculator, you have to really watch your parentheses. And you guys can always ask me how you do the parentheses for that. So here I'm going to do this. Where's the square root? There's the square root. 16 squared plus 10 squared minus 2 parentheses 16 close parentheses 10. This is just to show that I'm multiplying. Cosine of, and luckily I really like the Desmos calculator because it recognizes if you type the word cos in there, it knows it's cosine. And 22 degrees. And that's going to give us 7.7. So this is about 7.7. This one I didn't have to do. Whoa, what are we talking about here? Why is that wrong? Incorrect. The general relationship between cosine and the opposite angle triangle. What are you talking about? 16 squared. So 16. So c squared plus a squared plus that. Round 2 decimal places. Angle C is this much. What is the length of C? I don't know how else we can do this. Desmos 16 squared. A squared is 16 squared. B is 10 minus 16. Let me see if I typed anything wrong in here. Nope, all of this is fine. I'm going to try. Wow, it literally wanted another 0. Okay, I was like, Desmos, you have to account for round off error, but apparently they really wanted you to put that extra 0 so they can account for round off error. It's really weird. I highly recommend using Desmos when you're using your tests. It's just going to help you out that much more. And in summary, so way back when we did do the law of sines. So here's the law of sines. It's just saying the side over the sine of its opposite angle. So the side over the sine of its opposite angle is always equal to any other side over the sine of its opposite angle. And law of cosines just says a side squared is equal to the two other sides squared added together. So first you square it, then you add it to the other one squared, minus 2 times both sides times each other times the cosine of its opposite angle. So this one, make sure you have these things written down somewhere. It's really going to help out a lot. All right, guys. So I will try to do step-by-step Kahoots to help you guys understand these a little bit better.